Okay, I'm going to work you through two uniform motion problems, which are a variation of weighted average problems. In one, the two objects are going to be moving in the same direction, and in the other, they're going to be moving opposite directions. Now, if they're opposite, they can either be heading towards each other or away from each other. So there will be a little bit of difference, maybe from the ones that I show you. But in the first one, they're going the same direction. Two cyclists begin traveling in the same direction on the same bike path. One travels at 20 miles an hour, the other at 14 miles an hour. So if they're starting at the same place, they're never going to catch up with each other. One's just going to continue to get further ahead. So after how much time will they be 15 miles apart? So if I'm looking, the things I have here are, I'm dealing with distance, rate, and time. So I know I'm going to be using this formula somewhere in there. So I'm going to go ahead and organize a chart that gives me those three things. So I have the first bike and the second bike. I'm going to figure out their distance, rate, and time, and then, of course, how they relate to each other. Now the rates are given clearly in the problem. Bike 1 is going 20 miles an hour, and bike 2 is going 14 miles an hour. Really, that's all the information they give me in this problem. So let's see. I also know I'm looking for when they're going to be 15 miles apart. So I need to see when basically the distance of biker 1 and the distance of biker 2 has a difference of 15 miles. So what I really need to figure out is how I can represent distance. What the question is saying is after how much time. So that's what I'm going to name my variable. And I actually can give them both the same time because I'm really, once they're 15 miles apart, one hasn't driven further than the other, or for a longer amount of time, I should say. So I'm going to use the same variable. Now distance, I don't have anything here, but I don't want to introduce another variable. So that's where this formula comes in. I know distance is rate times time, so I'm just going to multiply. And since I already took the time to write the equation in words, all I have to do is substitute. So the distance of bike 1 is going to be 20x. The distance of bike 2, 14x. So the difference has to be 15. So when I subtract, I get 6x equals 15. Divide both sides by 6, or multiply by their reciprocal. And I'm going to get x equals 2.5. 2.5. Now if I look back at the question, remember they're asking how much time. And since the rate is given in miles per hour, this is actually going to be 2.5 hours. After 2.5 hours, the one guy will have pulled 15 miles ahead of the other. One more problem. This time I have two objects moving in opposite directions. So I actually want to find out when the distance between them is 150. The two commuter trains are carrying passengers between cities. One's traveling east and the other's west. Their respective stations are 150 miles apart. Both trains leave at the same time, one traveling at 55 miles an hour and the other at 65 miles an hour. When will these trains pass each other? Okay, so what I want to do is organize distance, rate, and time again because those are the three items that are kind of showing up in this problem. So I have train 1, and I have train 2. Distance, rate, and time. Alright, my rates are given to me again. 55 miles an hour for one, 65 miles an hour for another. Now if I look, again, they're asking when will they pass, after how much time. So since they started at the same time, they're going to pass each other at the same time. I'm just using the same variable. And I can also say, just like in the last one, distance is rate times time. Alright? Now the question is, what am I going to do with those distances? Well, I want to know when they're going to pass each other. So, I need to know when each train, the combination of them is 150 miles so that I know they've covered the whole distance. So I'm going to do the distance of one train plus the distance of the other is going to equal 150. One's going to travel further. They're not going to meet in the middle, but after they've gone a total of 150, that's when they'll pass each other. So I'm just going to add up my two amounts then. And then divide by 120. X equals, well, if I'm dividing, I can cancel that 0 on both of them. 12 goes into 15 one time, and 3/12 is a quarter. So 1.25. Remember, they're asking time, and since my rates are given in miles per hour, I want to stick with hour. Alright? Now again, you can plug it back in and check just like you could any equation. There will be mostly these kinds of problems if I'm talking about uniform distance, but if you have a question on another one that pops up, make sure you come and ask.